Let's go over topic 1.5, solving equations and inequalities by graphing. So we are so used to solving equations such as this by using our algebra and solving for x, but we can also do it by graphing. And remember that an equation is simply made up of two different expressions, and they are equal expressions. So whenever we solve for x, we're finding that value that's going to make the equation true. In order to do this by graphing, what we'll do is we will break apart that equation into two separate equations. So we'll take the left side, set it equal to y, and we'll take the right side and set it equal to y. And we will graph each of these individually and look for the points of intersection. So here we are. Here's a graph. So now if you notice, when we graph each of these, this is y equals 5. This one is the negative 3x plus 20. So right here, the graphs intersect at x equals 5. So we can see that is a solution. And if you want to check that, you can come right back up here and substitute 5 in. Do we get a true statement? So negative 3 times 5 plus 20. Does it equal 5? That's negative 15 plus 20. Negative 15 plus 20 is 5. So this is a true statement. So therefore, 5 is a solution. Now again, too, let's do it the way that we are so used to doing it. Let's solve it algebraically. I would subtract 20 from both sides, and I get negative 3x equals negative 15. Divide out the negative 3, and again, we are left with x equals 5. So now let's go ahead and do the triads. These are from your companion book, and we're going to use a graph to solve the equation. Let me pull Desmos up, and we're going to take a look. What you're going to do, before I put Desmos on the screen, what you're going to do whenever you're entering these into Desmos, you're going to set your first line will be one side. So we'll say 5x minus 12. Your second line, whenever you have a constant, and it's only when you have a constant, you will have to input y equals 3 into that line. So let's go ahead. Let's take a look at Desmos. Okay, let me pull this down. So the first portion of my equation is 5x minus 12. 5x minus 12. Then I'm going to just click underneath to do my second line, and this is where I have to use y if it's a constant. Y equals 3. Okay, so here is our graph. And what's really neat about Desmos, and because I clicked, it turned the little points off. But you can get those points of intersection. Well, usually those key features of the graph will automatically show for you. And I can even just click on that. It's going to hold that ordered pair. So your solution here, and remember your solutions are x values. So I can see my solution to this one is x equals 3. So my solution here is x equals 3. Now let's take a look at this one. And again, one line will be this portion of the equation, and the second line will be this portion of the equation. To delete a line, all you do is click the X. Okay, so I have a negative absolute value. So we have negative absolute value is that little a with the two vertical bars, and it was x minus 2. And my next line is a negative 1/2. So to enter a fraction, we're going to do 1 divided by 2. And then be careful, because if you type x in right now, it's going to go in your denominator. So just kind of click up and get it right there in the middle. So negative 1/2 x minus 2. Okay, there we go. And now let's take a look at what we got. And if you notice too, we're down a little low, but automatically Desmos highlighted that point of intersection. Once I click and move the graph, though, it goes away. So let's just click on that again. 0, -2, and here's another one, 8, -6. So in this instance, my equation has two solutions. See where the graph intersects? At two different points. One is at x equals 0, and the other is at x equals 8. So my answers here were x equals 0 and x equals 8. And again, to check these, if you plugged these values in, if you plugged in x equals 0, you're going to get a true statement. And likewise, if you substitute 8 in for x, you're going to get a true statement. Let's take a look at this SAT problem. So here we're given a system of linear equations. We've got 3 different lines. And to find the solution when you have 3 lines, so far we've looked at 2 lines. This is as far as we're going to go with 3 lines in this class. You have to see where all 3 lines intersect. So the question is to ask, how many solutions does this graph have? And it's easy to kind of look around and count the dots, but that's not necessarily the case. If we just start out, let me highlight one of these linear graphs right here. Okay, so let's just focus in on this piece. So I can see, here's an x-intercept. I can see here we intersect the quadratic graph right here, and I'm also intersecting this line. So I have intersected, I've got all 3 graphs are intersecting at this point. If I come up here, well, the only other graph that this line will intersect when x is 0 is that quadratic. So that is not going to be a solution to the entire system here. The only one, we only have one. There are no other places on this graph where all 3 graphs intersect. So my answer here is going to be 1. And now let's look at doing inequalities. We're going to solve an inequality. On an inequality, when you're plugging this into Desmos, you're gonna there's no greater than in Desmos. So in Desmos, you would just literally input like x squared minus 4, and now these are y values. So this is your output. We want to see where your y value is greater than 0. And if you remember, this is y equals 0. And if we are greater than, we are above the x-axis. Because y equals 0 is the x-axis. So looking at this example, we can see if it's above the x-axis, we're looking at a positive interval. And any value of x that is going to be less than -2 is going to produce a positive y value. And you can even test that theory out. Plug in -25 in for x. Your answer is going to be positive. If you were to put any numbers in between -2 and 2, so say you plug 0 in, we can do that easily. If you put 0 in here, you get -4 is greater than 0. Well, that's false. But if we go from 2 on to positive infinity, so any number greater than 2, you're going to be positive. Your answer will be greater than 0. So here we go. Let's do some of these. And again, in Desmos, this is the part you're going to enter. Let's pull Desmos back over. I'm going to clear out my lines. And I have x squared plus 6x plus 5. Okay, so here's my graph. And I am asked to find the y values. So where x squared plus 6x plus 5 is greater than or equal to 0. Well, again, anything above the x-axis is positive. So let's find my x-intercepts. I've got one at -5, 0, and one at -1, 0. So that means, and again, this is a greater than or equal to, so I can include my x-intercepts in this one. So if my x values are anything less than or equal to -5, I'm going to get a positive y value. So again, if I can maybe stick in -10 into my function, or even look at it graphically, I mean, look at that. See, just because the graph doesn't show on the screen doesn't mean it stops. This goes on forever. So when x is -10, my goodness, I got to keep scrolling. Where is it? We're coming up on it. Right about in here, somewhere in here. -9. There. Right about in there, I have a y value. So just because it doesn't show on the screen doesn't mean it doesn't exist. This thing is going to go on for infinity. It goes on forever. So any of these values that are less than -5 are going to make this inequality true. And again, you could stick any number that is less than or equal to -5 into your original equation, and you're going to get a true statement. Your answer will be greater than or equal to 0. If we come over here, now let's check out this one at -1. So any value now of x that is greater than -1 is going to get me, again, a positive y value. It's going to be way up there. And again, I can do that. I can go on for infinity. So my answers here are going to be x has to be either less than or equal to -5, or they could also be greater than or equal to -1. X has to be less than or equal to -5, and x could be greater than or equal to -1. And again, too, if you would have any numbers between -5 and -1, any x values, and you plug them in, you're going to get a negative number. This would not be a true statement. Now let's take a look at the last one. This one is two linear functions. So again, when you enter this in Desmos, you can just break this apart. 7 minus 3x. Let's take a look. And here it's going to be kind of helpful to pay attention to the color of your graph. We've got x plus 3 and 7 minus 3x. Okay. So x plus 3 is purple, 7 minus 3x is the black. And I want to know, where's x plus 3, this purple one, greater than 7 minus 3x, the black one? And again, when we're talking about these functions being greater than or less than each other, we're looking at y values. So if we come over here, we can see right here is our point of intersection. Now look at this purple graph, the x plus 3. These y values here are greater than the y values of my 7 minus 3x. So therefore, any value greater than 1, remember we started out with a greater than statement, there was no equal to, so 1 is not included. So any number greater than 1 is going to yield my y values, my x plus 3 will be greater than my 7 minus 3x. And again, to check that algebraically, just pick a point over, somewhere greater than 1, plug it in. Is it a true statement? So my answer here is x is greater than 1. On your homework, I expect you to use Desmos, and also on your test, when you have a test on this material, you will also be allowed to use Desmos. If you have any questions, please feel free to reach out and I'll be happy to help you.